Good morning. Now, good morning, dear students. You know what I'm doing today? I'm taking some problems of momental ellipsoid. Now, let me take one more important problem of the momental ellipsoid. That problem is to find the equation of momental ellipsoid at the center of a cube whose side is given as 2a, referred to its principal axis is this much. Now, referred to its principal axis means, it means that principal axes are the axes about which product of inertia vanishes. Okay, so we have to find the momental ellipsoid of what? Of a cube. Okay, so first of all, you will draw the cube. First of all, we will draw the cube, and this is the cube. Now, here a line passing through its center of gravity, that is taken as x-axis, and another line perpendicular to it is y-axis, and the third line perpendicular to it is z-axis. So this is one edge of the cube, and our axis origin is at the end of one edge. That is what written. Momental ellipsoid at the center of a cube. We have to find it at the center of gravity of the cube of side 2a. This side is 2a, this side is 2a, all the three sides, because it is a cube, they are through a, referred to its principal axes. Now, what are the principal axes? Principal axes will be the axis about which products of inertia vanishes. That means they must pass through the center of gravity. So, in order to solve it, we have to find momental ellipsoid about one edge, one end of the edge. So, about this very point O. So, let us assume O to be the corner of a, and G is its center of gravity. So, what will be the coordinates of center of gravity? They will be, x coordinate will be OG, y coordinate will be 0, z coordinate will be 0, and you may be knowing that what is the value of OG? OG is a root 3 if 2a is the length of the cube, breadth of the cube, and height of the cube. Okay, so this OG will become a under root 3. I hope this point is clear to all of you. And why we are doing this? Because you know the equation of momental ellipsoid is ax square plus by square plus cz square, and then three more terms d, e and f. So our target is to find the values of these 6 quantities a, b, c, d, e, f, and then we put them in the equation of momental ellipsoid. So here, what is A? A is the moment of inertia of this cube about x-axis. So that we have already evaluated in the questions earlier. And if in the exams this question is asked, you are not supposed to evaluate it again. It is a standard result. So moment of inertia about x-axis it is 2 by 3 ma square about this axis, 2 by 3 ma square. So our target will be to find the values of B, C, D, E and F. Now what is B? B is the moment of inertia about y-axis. So what will happen? We will be using the theorem of parallel axis, and it is very simple. You know the moment of inertia about x-axis, and then mass into this perpendicular distance is squared. That will give you the moment of inertia about y-axis as well as about z-axis. So let us substitute the values. It will become 2 by 3 ma square plus mass into mass into perpendicular distance square, that is OG square, and OG is a root 3, so it will become 3a square. Is that okay? Now that gives you 11 by 3 ma square. This is the value of B as well as it is the value of C. Okay. So once you know the values of A, B, C, now the next is to find the value of D, E, F. And you know the procedure how to find D, E, F. They are the products of inertia, and you know the coordinate of center of gravity are OG, 0 and 0. So what will happen to the products of inertia? All of them will vanish, and it is obviously clear from here as well about its principal axes. So these axes are the principal axes. What are those axes? They are the axis passing through the center of gravity, and that is why the value of D, E, F will be 0. Otherwise also you know the value of D, that is the product of inertia about x-axis, that is summation m y z. So what is yz? These are 0 and 0 here. These are the coordinates x bar, y bar, z bar. So from here you get the product of inertia. So that is why D vanishes. Then about y-axis, that means OG into 0, that also again vanishes. And F, product of inertia about z-axis, so that is summation mxy, and this is x, this is y. So again it will be 0. So D, E, F, all three vanishes, and we found the values of A, B, C. Let us put them in the equation of momental ellipsoid. So we will be getting this. But what we want to get is this much. That means take this m on the right hand side, this a square on the right hand side. They will be merged with the constant. So you will be getting 2 by 3. 3 also you can take, that can also be merged in the constant. So you will be getting 2 x square plus 11 y square plus 11 z square is equal to a constant. This constant is multiplied by 3 divided by ma square, which is again a constant. Okay, so that finishes the questions of momental ellipsoid. Now next time I will be taking some problems of principal axes. That's all for today. Thank you very much.